places behind the decimal. So the same number of places behind the decimal is the multiplicand. Why can I not talk today? The multiplicand and multiplier combined. So what that means is, see this problem right here? It's got 1 and 2, 3 decimal places. So it's got 3 decimal places. So my answer is going to have 3 decimal places. Okay. And then I just multiply it regular and put my decimal place back in. And we'll get to that in a minute. In order to make a divisor a whole number, you multiply it by a power of 10. Now, I don't do this part, okay? So I just divide them. So like I would put the 43.7 in the little house and divide it by 19. And you bring that decimal directly above into the answer. So this decimal place, I bring it directly above here as part of the answer. And I just divide it like that decimal's not even there. Okay, so that's how I'm going to set these up. All right, so we're going to actually get into some problems now. Remember, we talked about how if the signs are the same, the answer will always be positive. And if the signs are different, then the answer will always be negative. All right. So we're going to get into some problems down here at the bottom. Hopefully you'll write some of them down so you'll have them to look at. All right, so this first one, 4.5 times 3. I'm going to multiply it as if the decimals are not there. So I'm just going to do 45 times 3. All right, and then I'm just going to start multiplying it, okay? So 5 times 3 is 15. And then 3 times 4 is 12, plus 1 is 13. Now, to get my final answer here, I go back to the original problem and I count how many decimals. Yep.
Wouldn't it be 1, 2, wouldn't it be 0.135?
Well, no, because that's what I'm going to say. So let's go back to the problem. How many decimal places does this problem have? It just has 1 decimal place, which means the answer is only going to have 1 decimal place. So I always start here and I only put 1 decimal place in because the problem only had 1 decimal place in it. And my answer, it was a positive times a positive, so my answer's positive. All right, this one, -5 divided by -2. So I know that a negative divided by a negative is going to be a positive, and I'm going to divide 5 by 2. All right, 2 goes into 5 2 times. 2 times 2 is 4. I subtract and I get 1. Now we are doing decimals in this, so I am going to add a decimal place and a 0 and bring down that 0. 2 goes into 10 5 times. 5 times 2 is 10, and I don't have a remainder. So I know that -5 divided by -2, and I bring this decimal up, is 2.5. All right, I'm going to let you all multiply this next one. So I'm just going to write it for you. And remember, we ignore our decimal places and just go ahead and multiply this. So 156, I'm going to line that up a little bit better. 156 times 2, and do it just like this one, and then we'll put that decimal place in. So go ahead and work it out yourself on your paper.
Miss Wilson,
Yes.
wouldn't that be negative 13.6?
On what?
On the one we're doing.
No. So I'm taking 15.6 times 2, and you're going to start multiplying. We're not going to talk about the answer yet until you multiply, okay? We'll do 2 times 6,
Okay.
then do 2 times 5, and then do 2 times 1. All right. So 6 times 2 is 12. And carry my 1. 2 times 5 is 10. Plus 1 is 11. Carry my 1. 2 times 1 is 2. Plus 1 is 3. So I got 312. But this was decimal. So I'm going to go back to the original problem and count how many decimal places I have. In this problem, there is only one decimal place right here. So I'm only going to put one decimal place in my answer. Okay. Are there any questions about that one? Anybody? Okay. So this next one, 4.32 divided by 1.2. So I'm going to put that 4.32 in the little division house, and I'm going to put my 1.2 on the outside. Now, when you divide decimals, you do have to remove the decimal places on the outside of the house. So I don't know if anybody remembers this from, I think it was like 6th grade, maybe 5th grade. So when you divide, you've got to take this decimal and move it over one spot to get rid of the decimal on the outside, which means I also need to move this one over one spot. And then I'm going to divide this as if this was the number 12. Okay. So 12 does not go into 4. So I'm going to try 12 into 40. Mute it.
Turn off your mic.
Okay, so 12 goes into 43. I know that 12 times 4 is 48, so that's too much. So I'm going to do 12 times 3. 12 times 3 is 36. And I'm going to subtract. Okay, so I'm going to borrow there. So 13 minus 6 is 7. And 3 minus 3 is 0. And then I'll bring down the next number. Does anybody know how many times 12 goes into 72? All right, 13. Tell me.
13.
6 times.
6 times.
6 times.
Yeah, 6 times. 6 times 12 is 72. And I get 0. So 3.6. And guys, I am not telling you that you can't get out your calculator when you're done and check it. So you're going to do 4.32 divided by 1.2, hit enter, 3.6. I know I got it right. Okay. I'm not telling you that you cannot check it with your calculator, but on your assignment, I need to see your work. Okay. All right. We're just going to do a couple from down here, and then we're going to move on to the fractions. All right, so it says if the signs are different, then the answer is negative. So this is a negative times a positive, so I know that my answer is going to be negative, but I'm just going to multiply it just like I've done the other stuff. So I'm going to take 2.5, but I'm just going to ignore the decimals and multiply it by 7. So why don't you all multiply that and put your decimal places back in? Okay, so 5 times 7 is 35. 7 times 2 is 14, plus 3 is 17. And then I know that I have one decimal place, so I'm going to put one decimal place in. And I know that a negative times a positive is a negative. And once again, there's no reason you can't get out your calculator and check it. So negative 2.5 times 7, negative 17.5, bingo. Somebody's mic's not muted. All right, I'm going to do one more here. So 8.2 divided by negative 4. So the 8.2 is going to go in the house, and the 4 is going to go on the outside. Now, this one's different than up here because the outside number did not have a decimal place in it. So I'm not going to have to move anything like I did here. So this one's ready to go. Okay. So 4 goes into 8. 4 times 8, 2 times, or 4 times 8, 4 times 2 is 8, is what I meant to say. And then I'll bring down the next number. Can 4 go into 2? No. So it goes in there 0 times. And then I'm going to add another 0 and bring that down. How many times is 4 going to 20? 5. It goes in there 5 times. So 5 times 4 is 20. And I have 0 left over. Now, this was a positive divided by a negative. So my answer is going to be negative. And let's check it. See if you can see this a little better. Okay, so I'm going to do 8.2 divided by negative 4. Yay, I'm right. But I want to see your work like I'm showing and use this as a backup to check it. Does anybody have any questions right now about decimals? I know decimals are pretty much everybody's least favorite. I know most people would rather multiply and divide fractions than multiply and divide decimals, but we got this. We're going to work on it for 3 days, so it's not like I'm going to be like, hey, tomorrow quiz. Like, we're going to work on this. Anybody have any questions right now about decimals? All right, we're going to do a little flipsy-roo here. All right. I love to multiply and divide fractions. It's just so much easier. Okay, and we're going to follow our same steps, except you don't have to make a common denominator. Okay, somebody raise their hand. Who's raising their hand?
I'm gonna go use the restroom. I'll be back.
Okay, that's my favorite part, is that we don't need common denominators to multiply and divide. But you are going to change each mixed number to an improper fraction first, just like we did before. All right, after we change them to improper fractions and it's multiplication, I just multiply straight across the top. So I multiply the numerators and I multiply straight across the bottom. I multiply the denominators. And then I'll reduce if I need to. Not all of them need reducing, but some of them do. All right. Important. Both of these that I'm starring are super important and you need to write it down. So first of all, you don't need a common denominator. So that's very important to write down for multiplying and dividing. You do not need a common denominator. And when you divide fractions, so on dividing them, you keep, change, flip. Has anybody ever heard that before? Yeah? Yes. All right. So keep, change, flip. So you're going to keep the first one. You're going to change the sign to multiplication. And you're going to flip the second fraction. So that's for when you are dividing. So both of these star things should be in your notes. All right. So same rules apply for decimals and fractions. If the signs are the same, the answer will always be positive. And if the signs are different, the answer will be negative. Yes, question? Question? Anybody? Somebody's raising their hand.
Angel?
Well, if you're raising your hand, tell me what your question is.
Miss Wilson?
Yes.
So, what do you mean by no common denominators?
So, like when we were adding and subtracting fractions, like we had to look at the denominators, the bottoms, and make them the same number.
Yeah.
Right? With multiplying and dividing, you don't have to. So you don't need a common denominator to be able to multiply and divide fractions.
Okay. I think I get it.
All right. Well, we're going to go over some down here, so don't stress yet.
All right.
Okay. So here's the first one that we're going to do, and hopefully you're putting some of these in your notes. So 3/5 times 2/3. So I don't have any mixed numbers, so that's good, which means I'm ready to multiply these. So when I multiply, I just multiply straight across the top, straight across the bottom. Okay. So I look at the top. 3 times 2 is 6. I look at the bottom. 5 times 3 is 15. So multiply straight across the top, straight across the bottom. And then if I cannot reduce it, I would be done. But this one does reduce. And I'm going to upload a multiplication chart in our folder. But if you need help with reducing, this will help. So what I'm going to do is I'm going to look for 6 and 15 in the same row. Okay. So I'm going to start down here. No 6. Oh, here's a 6, but no 15. No. Oh, right here. 6 and 15. That means they're both reducible by 3. So I'm going to reduce both of these by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. And I'm done. So reduce it if you can. So that one could be reduced.
Oh.
And my answer is positive because this was a positive times a positive is a positive. Same sign. They're both positive answers. All right, let me do another one. So this one, there's no mixed numbers going on. So I don't have to change anything to improper, which means I'm ready to just multiply straight across the top, straight across the bottom. Does somebody have a question? Okay, then. All right, so 5 times 3 is 15. 6 times 4 is 24. And a negative times a negative is a positive. So it's positive 15 24ths. And then I'm going to look to reduce this as well. Okay. So I'm going to go to my multiplication chart. Like I said, I'll put this in a folder for you all. I'm looking for the largest row that has 15 and 24 in it. So like here, no 15, 24. Oh, here's 24, but no 15. There's 24, but no 15. There's 15, but no 24. Oh, there's 15, and there's 24. So this one is also reducible by 3. So 15 divided by 3 is 5. 24 divided by 5 or by 3 is 8. All right, I want you all to try this one real quick, the one that I just circled. I want you to try that one. Okay, so multiply straight across the top. So 7 times 1 is 7. Straight across the bottom, 10 times 4 is 40. A negative times a positive is a negative. And 7's a prime number. It only is divisible by 1 and 7, which 40 is not. So that's it. You can't reduce it. Somebody have a question?
I can't hear anything.
You can't hear anything? Is your speaker on, whoever said that? Does anybody know who said that?
It was 80.
It's 80 Hampton. Can you turn on the chat so we can text him?
Yeah. Hold on.
All right, I'll text him that. Try to.
All right, well, I'm going to keep going. Hopefully he can fix it. He can watch it later if he needs to. All right, I'm going to go back up here and I'm going to do some division now, okay? So I'm going to go back up here with division. In math, division is something that you cannot do with fractions. So that's why they came up with keep, change, flip. So what that means is you keep the first one. Is everybody watching? You keep the first one. You change the division to multiplication. So that's the change. Keep, change, and then I flip this. So that's -5/4. So I keep, I change, I flip. And then it's just like the other problems. So I'm going to multiply straight across the top. 3 times 5 is 15. Straight across the bottom, 10 times 4 is 40. A negative times a negative is a positive. And then 15 and 40, it ends in a 5 and a 0, which means they're both reducible by 5. 15 divided by 5 is 3, and 40 divided by 5 is 8. All right, you all try this one, the one that I just started. Okay, so it's division. So I keep the first one, I change it to multiplication, and I flip the second one. Keep, change, flip. And then I multiply straight across the top. 2 times 2 is 4. Straight across the bottom, 3 times 1 is 3. A negative times a positive is a negative. And 4/3 does not reduce, so that's it. All right, does anybody have any questions about the division part? Now would be the best time to ask. Okay, last one. All right, I'm going to do this one. Can anybody tell me what I need to do first on this one? Somebody just unmute and tell me.
Change it to an improper fraction.
Yep, change it to improper. So 2 times 2 is 4, plus 1 is 5. Okay, and then after that, it's a multiplication problem. So I multiply just straight across the top, straight across the bottom. So 5 times 3 is 15. 2 times 4 is 8. A positive times a negative is a negative. And 15/8 does not reduce, so that is it. All right, question time. Questions. Anybody? Anybody, everybody? All right, hand raise.
May I use the restroom?
Yeah. Anybody else have an actual math question? Hand raise. Who?
Miss Wilson,
Yes.
don't you have to flip the 3/4?
No, because see, it's already multiplication.
All right.
The only time that you'll do keep, change, flip is when it's division.
Wait. Oh, that was multiple. Oh my god, I'm so dumb. I
No,
thought
you're
it was
good. You're good.
division. My bad.
Nope, you're good. So that one was multiplication. So that's why I did not do that. But only on division I do that.
All right.
Yep. Other questions? Okay, so I'm gonna go back to your all Schoology. Yes, question.
After you said we can put the K keep, change, flip. Can we just put after that? Can we just put only on division because some people get confused with that.
Yeah.
Put it on
Yeah,
multiplication.
so that's why when I went up here, like I put division is keep, change, flip.
Yeah, it says division right there, guys.
Yeah, division is keep, change, flip. And then multiplication, you just multiply numerators, multiply denominators, and reduce. And we're going to do another video over this tomorrow, too. All right, so our homework is published in our folder. Does anybody else have any questions about anything that you can think of? All right, Jackson.